Hi folks, we're going to take a look at number 3 from Unit 5, Lesson 5. So here we have a spring that's pulled to its maximum extension and then is let go. All right, so we've got our wall, and we've got presumably a spring that is pulled to 32 centimeters and then is let go. And of course, what's going to happen is this is going to go back and forth. It tells us that the minimum distance to the wall is going to be 8 centimeters, and it takes 2 seconds to complete one full cycle. All right, so we have all the information that we need to set up a model for this scenario. Okay, so we have our maximum extension is going to be 32. We have our minimum is going to be 8, and so from here I can determine my A value. 32 minus 8 divided by 2, so 24 over 2 is 12, and we can determine our, so that was our amplitude, and we can determine the C value, which is essentially the location of the axis, and that's going to be 32 plus 8 divided by 2, so 40 divided by 2 is 20. So notice I'm solving this whole problem without actually having to graph it, okay? I'm just using the connection between the characteristics of the function and these parameters that are found in the function themselves. All right, so we know that the period is equal to 2, so that means that the k value is just 2 pi divided by the period, so just pi. Unfortunately, it shows a lot of examples where this is the k value. And let's determine what parent we're going to need to solve this. Well, we're pulling this spring and then letting it go. So that means that would be the maximum extension. So I'm starting at the maximum. So that means that I'm going to use y equals cos x, positive cos x, which starts at the maximum. So from there, we can now write our model. So y is just going to be equal to, so a is equal to 12, and it's going to be positive. Cosine of, again, pi x, similar to the last one, and then plus 20. And so here y is the distance in centimeters, and t is the time, this time here, in seconds. All right, and particularly what we want to know is when the spring is exactly 12 centimeters from the wall in the first 10 seconds. So this gives us a y value, because that's horizontal distance. All right, and what we end up having is a, oops, sorry about that, pi x plus 20 is we have, again, a linear trigonometric equation. So step number 1 is to isolate my trig expression, so cos pi x. And here, what do we have? Well, we're going to have 12 minus 20 divided by 12. So cos of pi x is going to be equal to, so what do we have? This is going to be negative 8 over 12. So that's going to be negative 2/3. All right. So let's keep going here. Now that we have a single trigonometric expression equal to a number, I know I can find 2 answers for pi x, one using my inverse trig function. So let's get our calculator here. Oh, turn it on. So what do we have? Inverse cosine of negative 2 over 3. All right, so that's 2.3. Or pi x can be equal to, again, using the related acute angle, 2 pi minus 2.3. So that's equal to 2 pi, 6.28 minus 2.3 gives us 3.98. All right, and how can we generate more answers? Well, first of all, we're going to have to solve for x. Almost forgot about that. So x is equal to 2.3. Well, let me do the second one first. So 3.98, and we're dividing by pi. So that's 1.27. So x is equal to 1.27, and from this one here, 2.3 divided by pi is 0.73. All right, so now that we have these 2 base solutions, we can just keep adding the period to find other solutions. So our answer here, so here we'll say x in seconds. So I don't have to write it each time. So x can be equal to, and what I'll do is I'll make two columns here just so I can easily write up my answer. So I know one answer is going to be 0.73 seconds, and then I'm just adding 2 every time because that happens to be the period of this trigonometric expression. So what do we have? We also have 2.73, we have 4.73, we have 6.73, 8.73, and we're going to stop there because if I go one more, I'm going to go beyond 10. But we also have 1.27, and then we're just going to keep adding 2. So 3.27, 5.27, okay, 7.27, and then finally 9.27, and all in seconds. Okay, so that means that the spring is going to be 12 centimeters from the wall, at 10 different times in the first 10 seconds. All right, so just to recap again, start off by creating our model. In this case here, they gave us a specific y value, which produced a linear trigonometric equation. And then from there, we solve for the trig ratio. We then use our inverse cosine and our related angle identity to find two answers. We solve for x and then use the period of this trigonometric expression to determine all the possible answers which fell within our range of values. Okay, that's it for this one.